All right, so here's our last one. So for examples 1 and 2, we've had polynomial functions happening. We had a linear function, we had a quadratic function, we had a cubic function. So we've been dealing with all the different polynomials that are happening out here. So with this, the last one is our rational function. So with that, and we haven't done all the polynomial functions, but we've had some. So here we're going to do a rational, and so with this part, we're going to graph them out, and we're going to see where the rational function is greater than or equal to 2. So in Desmos, let's go ahead and type this in. All right, now with this, you can put them both together in here, but when we actually talk about the shading portion of it, the shading part actually tells us where the function exists, or where the true portion is, where it is true. Now with this though, it doesn't tell us whether it's an open or closed circle. Now with that also, you can't just assume, oh yeah, because it's an equal to sign, everything's going to be a bracket. You can't do that. So just because it's greater than or equal to does not mean that your answers will have brackets on both sides of it. So with this one, we're going to have that exception to the rule. So with that, we're going to take a look at what's going on. We have the function here, x plus, let's see, we need to zoom out. So we have our function here, x plus 1 over x plus 3, greater than or equal to 2. And again, we're trying to figure out what part of the function, what part of this function is actually greater than or equal to 2, where this is true, the x values. So the domain where x plus 1 over x plus 3 is greater than or equal to the number 2. So that's what we're trying to find. So if we look at this part here, and we understand what's going on, we can see that right here, that's where it's equal to, that point. So that point of intersection is -5, 2. And again, we're talking about our domain, so we're talking about the x values. So we know we're going to start at -5 at some, and that's going to be part of our answer, I should say. And we're talking about stuff that is greater than 2. So the only part of this function that is actually greater than 2, greater than or equal to 2, I should say, is from this point and up this way. But before we actually go into this, like, blah, 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 this is your answer, let's talk about rational functions again. We know we have vertical and horizontal asymptotes happening. We can see there's a horizontal asymptote somewhere right in here, like at x equals 1. Sorry, y equals 1. We can see there's an asymptote there. But also there's an asymptote at x equals -3. You can see that right here. So x equals -3, there's a vertical asymptote happening. And when it comes to our problem here, we know vertical asymptotes. Let's put it off this side here. Vertical asymptote, we set denominator equal to 0 and solve for x. And because factors don't cancel out here, it's not a hole in the graph. It actually is going to be a vertical asymptote. It's not disguised this time. It's not a hole in disguise. So when we solve it out, we get x equals -3. So it's a vertical asymptote there. And again, that's what we just said on the graph. So we have the verification there. All right, so with this, we know that it's going to start at -5, that it's actually above the x-axis. So this is our domain. We're going to start at -5. And then it's the line, because we know when it comes to our rational functions, this function goes up forever and ever and ever and ever and ever. It's getting closer and closer and closer to 3. So as x is approaching 3, the y value is going to positive infinity. So with it, we will never touch 3 because that's where the vertical asymptote is. It gets closer and closer to it, but never touches it. So when it comes to our domain here, we're going to say from -5, where it starts, to -3. At -5 is where it actually intercepts, so that's where it's equal to, and we need the equal to part because it's greater than or equal to here for the function, or for the inequality. And then the other part is because it's an asymptote there, it will never equal -3 because at -3 is an asymptote. It doesn't exist. So that means here we're going to put a parenthesis at -3. So our domain will be from -5 to -3.